Hey, how's it going, everyone? Getting things set up. Good to have you here. All right, let's see here. Clicking a few buttons. Got a good, strong internet today, and I figured it out. If we have weird internet, I figured out how to do a seamless transition to 5G as opposed to an interruption like we had last time. So just in case if it happens, I'm ready to go. Well, unless there's like a catastrophic, then there'll be a blip. But you know, if it's smidgen. Hey, bro, how's it going? RUX 10,000, good to see ya. All right, hey Goku, good to see you. Welcome on in. Happy Thursday. Oh wow, can you believe it's already only 2 days left until the weekend. I'm excited. We're gonna be doing some function tools today. Did a quick little Gemini query. Like, let's look at some function tools, and we're gonna try them out. I've not really used a lot of function tools in Python. I'm pretty excited about it. I'm pretty excited. This one looks neat. The partial method. I don't know what it is, but we're gonna find out. Power base exponent, and then you create a cube, and it looks like it's a function that wraps a function, which allows you to call into it. I think it's pretty neat. We'll try it ourselves. And also this idea right here, this LRU cache, I'm very interested in that. If there's something built into Python, usually you had to import another library that was external third party. functools is more of like, native, right? Isn't it? Is functools native? Hey, Aiden, good to see you. Torva, how's it going? Welcome on in. Good to see you. Happy Tuesday. Thank you for the party poppers, you guys. We're getting going. This is great. Happy to have you here. All right, RUX 10,000 also. We should make sure to do our memes. And you know what? You mentioned that you had a portfolio thing that you wanted to check out. We could do that as well. We could do that too. We could do that as well. All right, let's see. Where is our window? Okay, so function tools is the plan for today right here. Func tools. We're going to do that. All right, so let's see here. And yesterday we did the rich library. Thank you for the party poppers, you guys. All right, so we did the rich library yesterday, which was a lot of fun. There was a lot of pretty colors on the screen. I really liked it. Today we're going to do func tools, which is purely programming at that point. Just pure programming. So let's see. Let's close that, and then we'll go over here. Oh, also, let's see here. So vi function tools.py. So import func tools. I think that's what it's called, right? Let's double check. Here we go. So Python import func tools. Okay, that's good. When we will use the PubNub API today. Ooh, that's a good idea. I do have a plan for that. I'm actually kind of excited. So we are releasing a new feature. It's a new feature. It's coming out pretty soon, and I think it'll be a lot of fun. I don't know if it'll be tomorrow. It might not be. You know what? But I am excited about it. It's gonna be neat. Some of you have been asking to check out what what it looks like from different views in the room that I'm in right now. Yeah, we will be able to do that. I'm not going to say any more than that, but it's going to be pretty neat. And we'll be able to use the power of my API to do that. I think it's going to be pretty neat, and it will be real time. It'll be real time. All right, so we've got function tools. Devs release the product on weekends. I know, right, Goku? I know. We probably won't release it on Friday, right? Right? You don't deploy on the Friday for the weekends. Like Thursday is the cutoff day for deployment. Although if you're feeling up to it and you're ready to, maybe have to do any changes over the weekend, then Friday is up for it. All right, let's see here. All right, so there's functools cache or LRU cache. I want to try this one first. I think this is interesting. So there's a factorial. Interesting. Return if n is 0, return 1. Oh, it'll cache. That is neat. Okay, so if you have a very challenging, expensive compute. Hey, Savan, good to see you. Yellow, good to see you. Welcome on in. So if you have, this is neat. All right, so if you have an expensive compute operation, you can throw a cache around it. That is neat. That is pretty neat. I like that. Memoization, you got it. That's memoization. Bro, big thank you for remembering the portfolio thing. This is motivation for me, but only halfway. You're only halfway there? Okay. Sorry, unfortunately, portfolio thing is still not ready. Okay. I figured. All right, no worries. Sounds good. The bread and butter of the dislike leet code. Is it? We're gonna try LRU cache. So let's try this. So I'm gonna try typing it myself. All right, so import functools. All right, so from functools. we will import, let's see here, import the LRU cache, LRU underscore cache. Now, let's see if that works real quick. Python function tools. Okay. If I type Python properly, to get the Python in here correctly. Okay, that works. So then what we could do is say add LRU underscore cache on our function that we're going to define. We'll say Sivan, and we'll have some number, and we will try to do a bunch of operations while number less than, wait, so yeah, less than like 1,000 or something. I don't know. We'll return. Wait, so number equals number. So we'll do something like we'll do an increment, which is a really slow operation. Plus equals 1. It's not that slow, but you know, it's a little bit slow. The memes are loading. Sounds good. I know today we can create Python tool also. Sounds good to me. Goku, here's the link. What's the link? Goku, would you say? Can you rate my portfolio? Sure. Yeah, throw it in Discord. You get to throw it in Discord. Hey, far less than a few. Good to see you. We're doing more Python today. We're doing some functools. They're called function tools, which I am new to. I've not really used a bunch of function tools here, so I think it's pretty neat. All right, so plus equals 1 while, here we go. Actually, we got to put that here. While number, then return number. So this should always basically return essentially 1,000. Always return 1,000. So if we say Sivan 1. Oh, what we should do is we should benchmark it, right? We should benchmark it. LOU or cache for the win. You know it. We should benchmark. So let's see. Import time. All right. So I think, what is this? Python. This is going to be, so we're going to see if it actually is faster. Let's see if it's actually faster. And we'll do something like 10,000. So it's like a little bit more obvious. Okay. So import time. Import with proper spelling here. What's CPython? How did you know about this? How do you know about this, far less than a few? How do you know what CPython is? So CPython is the standard Python that's released and included, typically installed on your operating system. It is the standard CPython. C, basically, the C means Python's written in C. That's what that means. That's all that means. It means Python's written in C. That is literally what that means. Import time. Import a time. So time.time. Can we do that? Yes. Okay, so we say start. So we say start equals time.time, which will give us a precision, a pretty good precision, right? Into microseconds there. So it gives us microseconds precision. And so we run it and we say end equals time.time. And then what we can do is we can say print, took start minus end. No, end minus start. Okay, end minus start to get the latency. That's what we should do. So latency equals end minus start. Perfect. All right, good. Bro, come back in a few minutes time. It'll come back. It sounds good to me. Sounds good. Steven, is there a benchmark decorator? A benchmark decorator that will do. Can you decorate more than once? Can you put more than one decorator on there? Wait, so are we demoing memoization or LRU cache? Well, it looks like the LRU cache right now. We're doing LRU cache in the functools. But yeah, which isn't necessarily memoization, right? Memoization will, for every single, I guess, execution or function call or different steps, you can cache that compute. For this, though, it's just going to do a cache. So we're doing function tools today. Decorators, multiple decorators. Yeah. Stack as much as you want. Nice. That's what I want to try. All right, we could try that. Okay. So what we should do, here's what we should plan. This is what we should plan. We should build our own timer, right? So we do our own timer, so we do like a benchmark or something, or benchmark. We should do that. We should do our own, and then it will do this. It'll basically do the same thing. It'll wrap the function, start and end it, and then print out the time it took to run that function. That's a really good idea. I like it. I like it a lot. Yeah, it's different than memoization. You got it. Is field variable always stored in heap, like the persistent static variable field? Wait, so is field variable always stored in heap? Persistent static. If you define something up front, it's going to be and you like you allocate memory for it, that's the heap. If you sort of define a variable without mallocating it, at least in the C world, it's going to be a stack variable because it's inline. It's inline. C# window. Oh yeah, C#. I remember that. Looking to improve on that too. C# is pretty great. I like C#. That's a great programming language. All right, let's get going here. So I want to print the latency. Latency equals. Perfect. Okay. So let's try this out. Let's try this. And then we're going to convert it using function tools into, all right, latency. All right, so that's pretty fast. Let's make it a little bit more difficult. There we go. Let's 5x that. Yeah, that's a lot slower. All right, let's 10x it. All right, there we go. Almost. All right, so that is, what is that, 76 milliseconds? That's 76 milliseconds. That's pretty slow. If you had something like that in a game engine, it would be the slowest thing in the game engine. Now I'm wondering how our var is defined in Python. Methinks it's mostly the heap. It could be. It might be. Because, right, I mean, this easily could be a stack variable right here, right? Because it's not very big. It's small. It's tiny. It will fit easily into the CPU cache. It could do, and there's no reason for it to be a heap variable. So you never know. You're paying your bills with the government system with C#. C#'s great. I love C#. I really like it. I was at ASP.NET before C# was pretty interesting, to say the least. Hey Mohammed, good to see you. You joined the Discord yesterday. Where can I find the beginner's guide? The beginner's guide to Discord or beginner's guide to like different programming things? It's usually in the link share channel. So you go over to the link share channel here, click on that, and then you scroll up. Or what you could do is you could search for Python or whatever language you're looking for, and you might find a whole bunch of different resources that we've had over the past. And there's a lot of pages, so you have to like really scroll into it here. A lot of scroll. It's a lot of stuff. We've covered so much. It's ridiculous. It is a great, exciting adventure. Okay, let's get back over to here to the code. So what I want to do is create a decorator like Sivan was describing that will automatically do benchmarking. I want to do this. Let's do that. I really want to do that. Let's define our own decorator. That's what we do. You good to see you again in time. All right, Four Eyes Gaming, good to see you. You time really didn't match his mind. Oh, well, you know what? We're here now. Blazor was a breath of fresh air compared to many JavaScript frameworks. Farless than a few. The Blazor. You know it, the Blazor. Good old .NET. Goku. Thus, you know that there are programming languages named... Yep, I know about that. The brain. I sure do. Maybe make a thread? Wait, for Discord thread for specific languages. Oh, I see. Yep, a different channel. Yeah. We could do a different channel for each language. That would categorize it really well, because we're doing a lot of languages here. You got it. I mean, since Python is dynamic language and you can reassign a var to anything, it needs to know when to move to the heap. Good point. So you never know. All right, so this definitely. So what I want to do next is let's rerun this and see the second one. All right. So if the LRU cache worked, the second one should be faster, right? So we'll see two print statements on the screen. If the LRU cache works, the second one will have a lower number. Let's see if it worked. Do you guys think it's going to work? I don't know. We'll find out. We'll give it a try. Give me a neutron star level. Well, still don't understand dynamic types. You're right. Yeah, it is a known problem. It's flexible, but it has consequences. It's flexible with consequences. Yeah, cache works. Ideally, it should be instant. Yes, exactly. All right, let's try it out. And it is. Wait. Oh, it is. It's way faster. It looks like the number is bigger initially, but if you look here at the end, you see an E-7, which means it's essentially far many decimals below. So it worked. It worked. That's pretty great. That is pretty amazing. It's like a vase can talk. If a vase can talk, wait, what do you mean? What do you mean a vase could talk? All right, let's keep going here. How are you today? Hey, Sir Cats, good to see you, Sir Cats. We're doing pretty good. We're doing pretty good. We got stable internet today, so we're working out with a good stable internet and happy about it. Okay, so let's keep on going here. So we've got the function. Let's run it again. Double check. Okay, so let's see if we can make ourselves a decorator that does benchmarking automatically, so that it makes it really clean for us. So here, functools wraps. So this will be able to create our own decorator. At wraps function, use wraps here. Def wrapper, return wrapper. What is this? Actually, I don't know what this is. I don't specifically know what is this part. Do we even need this? I don't think we need this. I'm pretty sure we don't need this. Let me double check. What is this? All right. Using wraps to create a well-behaved decorator. Aren't they all well-behaved? Why? What does it mean? When writing a custom decorator, it's best to practice to use wraps on the inner wrapper function to preserve the original function's name, docstring, and other metadata. Really? I didn't know that was going to be an overwritten thing. I didn't know. Did you guys know that? Can you get picoseconds level performance? Well, is that picoseconds? I don't know. What is this? That's like so -7, right? So this takes this number here. And so let's go into Python. So let's go into Python and find out. All right. So that's the performance. However, I think the idea is it moves that decimal 7 places. So that will be 1, 2, 3, 4, 5, 6, 7. So if I do a dot here, that is it. Okay. So is this picoseconds? So what we can say here is this is milliseconds. So the first 3 digits milliseconds, then you got microseconds, right? And then you've got nanoseconds. So it is in nanoseconds right there. Vignesh, thank you for joining. Thank you for subscribing. Good to see you. Happy to have you here. Happy Thursday. You prefer English? Nice. English is a good language. You have a question. Python or C++? What is the best? Sir Cats, they are different. They're very different. Python, if you're going to do data science and you want a high-level language that is flexible and not that performant, let's be honest. And C++, if you need the utmost of speed and performance, right? C++, if you need all the performance and speed, you got to do C++. Or Rust if you want, right? Or Rust. Or, you can get over to Go, but now you're getting into slower zone with Go. What are your thoughts on Vi? My favorite. Far less than a few. Vim, the Vi text editor, my favorite text editor in the whole world, you guys. It's the best. It's the best text editor. It's so great. All right, so let's see here. So let's see if we can make a wrapper. So I want to say def benchmark, and then we have the original function, and then we have our def wrapper, and that will be, how do we do that? I forgot. All right, so okay, so we're going to args, I guess. Let's see, star args and star keyword args. So that way, whatever the original function is, it doesn't matter. We need to pass the data back into it. Okay. And then I want to return the original function. Okay. So we say return original. And then yes, we do. Okay. So it's basically the same as this. Okay. So that's that. And then do we do extra? Return the wrapper. Okay. So this is my benchmark. I should be able to do that. All right, for those who are watching, do you think this will work? I don't know. I don't know if it'll work or not. Why nowadays every app has to be a web app instead of native? Well, web app is a lot easier to build. A native app makes more effort. However, now that we have the AI, who cares how hard it is to make? Because it's an interface. With the AI to write your interface in Kotlin or Swift, does it really matter anymore? Hey, how's it going, Laura Maxwell? Good to see you. Just got here. Hey, we're only been live for 20 minutes, so You know what? It's good to see you. It's good to see you. Welcome on in. All right. Let me see here real quick. Click a few buttons. Okay. All right. All right. It'll eat all of your RAM in 10 nanoseconds. It could. It could. Well, that's for sure. That will happen. All right. So let's see if this works here. All right. Let's go Python function tools. Okay. So my benchmark wrapper did work. So what I want to do is I want to add this logic into it. So I want to add this logic. So let's see here. So we've got start and then do def wrapper original. Do we put the start here? I think we put the start here. Yes, that's what we do. And then we do the end and we get the result. Result equals. So that way we can return the result. All right. Results. Yeah. Let me do proper spelling. Laura Maxwell, good to see you. Welcome on in. All right. So we are doing some Python here. We're building a wrapper that does latency for us. Latency benchmarking. All right, so we get rid of that. Okay, so this, now, I think that'll work. I think that works. Let's find out. So this will be the original function, which we're wrapping, which is the Savan function. And should we do it before or after the LRU? We'll find out. Spelling, wait, Eyes for Gaming, thank you. Where's the spelling at? Let's see, start, looks good. So we don't need, so we won't need this anymore. Let's delete, let's clean this up here. All right, so we only need to run this a few times now. Let's run it 3 times. Let's run it 3 times. All right, start, result, result. All right, cool beans, nice. Cool beans, you guys. Are you building just for learning or is there no tool that fits for your use case? We're just learning, we're learning. So I've not really used the functools before. There's also a recommendation to use the wraps. So I'm going to try that as well. Let's do wraps. But before we do that, I want to make sure that this decorator actually works. So here's a wrapper. Here's the original function. I get the result. I get the end. I print the latency. And then I return the result. Oh, if I spell correctly. Yeah, you found it. I found the spelling error. I found the spelling error. Looks legit. Return. Yep. Gaming. Eyes for Gaming. You got it. You got it. All right. So let's keep going here. Okay. So let's run this again. Okay. Latency equals. Oh, did we not define latency? Oh, because we didn't calculate it. Okay. Hold on. Let me bring back the calculation. Redo. Put that here. Okay. Perfect. And we don't really need the end anymore because we have Eyes for Gaming. Thank you for paying attention. Thank you for paying attention. That made it better. That made it better. Okay, so now let's see if we run that. Whoa! Whoa! Look at that! Wow! Infinity speed over there. That's amazing. Wait, is it infinite speed because the LRU cached the benchmark itself? Is that the case? Is that the case? I don't know. I don't know. Let's find out. Let's do Savan. So let's print F string, open this, put this in here, and then we'll copy and paste that. For our listen to few, I think it's pretty neat. All right, so we got the value back. We got the value. That works. It's doing the trick. This is pretty neat. All right, let's see how many. Is it always going to be 0? Apparently, it's always 0. Infinite speed. It's so fast. It's so fast. It's infinite speed. Let's use it to crack encryption, right? Right, exactly. If encryption could work that way. Hey, how's it going there, Ethicrypt? Good to see you. Welcome on in. Spelling doesn't need to be good for brainstorming. Only counts when you want to execute the results. Yeah, exactly. Only counts when you need it to run. Can try benchmark a ping to Google. Oh, well, I mean, sure. Let's do it. Let's do that. All right, so let's do that. So we've got a benchmark, so we'll call to Google. So we'll say def fetch Google, and then we will return something. All right, so I need to say import requests. Then we'll say result equals requests.get. Let's say https://www.google.com. Okay, let's see how fast that is. Let's see how fast that is. And then we throw a benchmark in front of it. So, benchmark. Benchmark. Perfect. Okay. And then we could also do an LRU cache on that. So let's do that too. Let's do that too. Oh, this is great. We can cache the results. Let's return the results. Perfect. Perfect. Hey, Quantum, good to see you. Welcome on in. Happy to see you. Thursdays today, and it is a good day today because it's almost the weekend. Again, spelling bro requests. Oh, did I get it wrong? R-E-Q-U-E-S. Is that right? Requests. Okay. Requests. Yeah, I'm really good at getting the spelling in their way. R-E-Q-U-E-S-T-S. Okay. 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 Did we call? Oh, we didn't even call the function. We're only calling Savan. Okay. So let's call fetch Google multiple times. All right, there we go. Wait. Oh, there's no parameter. Done. Okay. Nice. Look at that. Fetching Google. And it's a cached result. Not only we benchmark it, but we cached it all in one. This is really powerful. You're a breed queen till I forget what it mean. Wait, a brief? Me too. You know what? Me too. I do the same thing. Drawing Brothers from a different account. Oh, Drawing Brothers. Hey, how's it going? It's good to have you guys. Hey, RUX, welcome back. All right, so let's get going here. I am interested in, don't you just decorators? It's such a powerful Python. Yes. Mm-hmm. Yep. I think you threw a emoticon in there, Savan, and it didn't show up on my side. Though I'm pretty sure you mean really like decorators. Now I do. Now I like decorators because, look, not only did we cache it, but we benchmark it too. Hey, Google Ads expert, good to see you. Welcome on in. Thank you for subscribing. Yeah, it didn't show. Yeah, it didn't show. It's all good. All good. Good to have you guys here today. All right, you love them. They are now my favorite thing. Although they are a little bit, it does take a while to understand what's really going on. What is even happening there? What is it? And then now you realize it's so good. It's so good, isn't it? Let's do the wraps thing that they were describing. So what is this? All right, so wraps the original function. Okay, so you need to do @wrap original. So apparently that's something extra. Do I need to say @sign? Yeah, I do that sign. Okay. And it didn't work at all. That didn't do anything. Did I have it right here? Wraps? Oh, I need to spell it right. Spelling again, you guys. Another spelling thing. All right, here we go. Okay. Apparently that's best practice. Apparently, you guys, that is the best practice right there, is using this. We're learning more at a time. We're learning more at a time. Bro memes dropped. All right, cool. RUX, thank you. Sounds good. How to use Python communicate with RS232? Any solution? What's RS232? What is that? What is RS232? Let me see what that is real quick. All right. RS232. What is this? Widely mature stand for asynchronous serial data communication between computers. All right, so there's I believe probably a port. So I think it's GPIO, right? Python GPIO. I think you can do Python GPIO, and then that'll work. You just need to get the address for it. So there's different options, I think. Those are general purpose pens, though. If you go a step further, you'll probably find the ability to work on this type of port. Because look, it's just a bunch of pins, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's like 9 pins, is that right? 1, 2, 3, 4, 1, 2, 3, and then 1, 2, 3, 4, 5. Yeah, 9 pins. Cool, learning new things. Me too. Serial communication, you got it. You love COM ports far less than a few? Nice. There's a library for that. Yeah, Stephen, read the message. All right, what'd you say? Quantum. Oh, hey, Steven, did you saw the video from Primogen I sent you in the server? Did I? I don't know. What was it about? I probably saw it. I probably did. I forgot what it was, though, because I watch a lot of videos. You saw the research paper on DC unit? All right. Nice. Cool, learning new things. All right, exactly, Comport. All tutorials find assembly code. Yeah. Hey, Code2 Billions, good to see you. Arduino, maybe check for that. Not sure if that works. Oh, that also too. That's a good point too. You could use that too. A lot of libraries. What is the Python library? So just say Python lib. That's it. I'm pretty sure you'll find something. Let's see. Oh, it's called the PySerial port. There you go. So PySerial. Pip install PySerial or Conda or UV or whatever you're using. And then you can serial port, baud rate, timeout, parity mode. If there's any parity, no parity, right? No parity. Stop bits, 8 bits size, byte size. So serial, right? One serial or parallel. What's the difference? PySerial, nice. Bro, got my phone's hotspot 5G data and a January month usage of 707 gigabytes. I only use like 9 gigabytes. That's almost a terabyte. That's amazing. Let's see here. Hey, Steven Savan again. Oh, how's it going, Shrivana? Or Shrivan? Shrivan Shirk. Good to see you. Welcome on in. Happy Thursday. Basically, Claude is written using React. Yes, I saw that, Quantum. I saw that. And it's ridiculous, right? Because the rendering the way that it's being built, they didn't need to do that. Because the terminal window is already fast enough. Even if you're not using an accelerated terminal emulator like Ghosty, if you're using just a standard terminal emulator that runs on CPU alone, it should be more than enough to have, a text area at the bottom and a scroll back. There's no need to build it the way they built it. Using React? Are you serious? Why'd they do that? Are they making plans for the future? Are they playing chess? Are they playing chess there? I don't know. It doesn't seem like it. Okay. So this was really great. This is functools. What else can functools do for us? So we've got a pretty neat, I want to do a few more here. Let's do a few more. They should all be 0. Yep. Once it gets memoized, or well, not memoized, once it gets cached, you get a good result afterwards. A good result. That is super fast. I use around 30 gigabytes a month on your router, and you max usage above 200. That is when I download GTA 5. Yeah, that game. Yep. Is GTA 5? I think it's a lot of gigabytes. It's a lot of gigabytes. Skills in your VPS traffic. How do you use React for a console app? Right? How do you even do it? Well, apparently you can use it as a construct for how things are supposed to be laid out from a graph structure perspective, a DOM perspective, right? You can render that DOM, and then you take the DOM, and then you convert it into the UI. I think that's how that works. And it's very slow because it's creating an abstraction layer for the representation of a UI that hasn't even been rendered yet. It's powerful. functools should have high order functions, I think. Yeah, let's see what else it's got. We're gonna go through it. Isn't some part of Windows actually React UI itself? Windows? Really? Is it? I would think not. I think it would be some sort of compiled language. Usually they don't get it for free on time, which you use to watch a recording while traveling to college. That is... Wait, I don't watch much internet at all? Oh, sick. I watch a lot of internet. I use a lot and I watch a lot. I use a lot and watch a lot. You can use Ink library in React to render UI in terminal. Ah, there we go. Windows with React. What? I know, right? WinBug. It would be a WinBug. All right, let's see what else we got with functools. Let's keep them going here. What else? All right, let's close these windows here. Okay. What else do we got? All right, so we've got wraps. We got the wraps. We did the cache. What's partial? Okay, so let's do a partial. I don't even know how that works. All right, functools, and then we'll do a partial. Let's do a different file. So we'll do W or E. We'll do function tools dash partial.py from functools import partial. And we need to define a function here. Windows start menus recommend section is written in React Native in Windows 11. Are you serious? Is that real? Are you kidding me? What? I can't even shut down. I know, right? That is remarkable. Yeah, that was ridiculous. Are you proficient in Java? I know Java. We can use Java. I don't want to. There's other languages that can achieve other things that are better. You can do better. Internet is free knowledge storage. Who is keeping up to date with what you say? That is the internet. The internet is free knowledge. You got it. He's proficient at coffee. Yeah, exactly. Far less than a few. Proficient at coffee. Using Java, you can talk to coffee cups. You sure can. That was one of my confusions originally. I'm like, what is this Java? What's a Java bean? Wait, what's going on? Is there cups involved? What is this? What is this Java? Should I learn JavaScript? Yes, code to billions. JavaScript is a foundational programming language that you want to learn for sure. Absolutely. You want Python, JavaScript as the foundational languages that most every engineer should know. JavaScript is the most widely used language, not only on the server, of course, from like Node.js proliferation, the web browser. It's used in the web browser, everyone on the website, and many mobile apps are also written in JavaScript. It's amazing how far JavaScript has gone. It's amazing. No one wants Java after Kotlin. You got it, Eyes for Gaming. Kotlin is the way to go. If you're thinking about writing in Java, write in Kotlin instead, or Scala. Other things more fun. Exactly. You got it. Coffee's equal to Java. Well, apparently, although I would say they're CoffeeScript. Oh wait, I forgot about CoffeeScript. Is that still around? That's very short-lived, right? That's very short-lived. Def far less than a few. We'll have a function that takes 1 and 2. We'll say a and b, a comma b. And we will multiply it, return a times b. Okay. And then we want to do a partial. Def partial. How does this work? All right, so cube. Oh, okay. Oh, I see. So you can set up the original. All right, so base. Okay, so basically you can fix one value. And then the other will be, what is power? How does that work? Power is, okay. So you put partial, the name of the function, and then you only keyword arg part of it. Your name is too long. I know, but you know what? It's there now. I'd love to work through you. No CoffeeScript must be dead now. It's got to be dead by now. It's very old. Java has metamorphed since its birth. Laura Maxwell. Exactly. All right. So it became CoffeeScript. Partial. See, far less than a few. Comma, and we'll say b equals 100. But we don't say def. We create we assign a variable. So we'll say mult 100 equals partial b. Or we can even say a. No, we'll say b. And then we run print. We'll do f. We'll do an f string. We'll say mult 100. And we'll send a 10. So that way the result should be 1,000 when we're done here. That should be 1,000. All right, let's see if that works. Python functools, and it will be partial. We did it, 1,000. All right, that was really easy. That's actually pretty neat. So if you have the need to always call a function regularly with a predefined a parameter, right? A predefined parameter, you're good to go. Which Linux? What do you mean? Always be a Linux girl. First true love. Nice. Linux. I like it. I'm also a Unix-based Linux fan myself. Question: how does Proxmox work? Oh, wait. What is Proxmox? Anyway, they call one type hypervisor if it needs an operating system to run anyway. Isn't it technically a type 2? Let's take a look. Proxmox. Powerful open source server solution. Develops powerful, efficient open source server solution for like Proxmox virtual environment platform backup server. What is it? A virtualization platform to run multiple operating systems like Linux and Windows and applications on a single physical server. So there's like a guest and a host when you're doing virtualization. you still need a foundational operating system, which will be the host. And the guest operating systems will be whatever you're virtualizing. Right? Isn't that how that works? Efficiently managed through a single web interface. So you need a base foundational operating system as the host first. Otherwise, you're in a weird situation otherwise, I think, right? And when you hear of Java and logic, why? Java is tough to learn. Java is fine. It's just verbose. It's extra. It's fine. It's just verbose and extra. It's verbose and extra. Let's see. Steven, you could explain how about the partial HTTP verb? What do you mean? Partial in HTTP verb. Savant, tell me, what is that? Update just some of the fields in a REST call? So that could be neat. That's actually pretty powerful. So what you're describing is you want to create a wrapper around the GET with predefined headers, so you can always make a call using the same headers, which makes it really clean. Is that what that is? I think that's what you're describing. So an operating system as an interface. You need a foundational OS. Sort of like a management OS. Exactly. You got it. Java is way too verbose. Yep. That's why Kotlin. Exactly. It's taken over the Java code base, especially the new ones. Recently, I can interface with Java and it runs on JVM Web Native. Exactly. Just use Kotlin. Java is legacy language at this point. That's it. You guys are on the right track. Hey, you know what? I've been saying that for 2 decades already. I've been saying that before Kotlin came out. And it's like finally true. It's finally true. All right. So let us see here. What else can we do? Let's close some of these windows. All right. So we did partial. We can do a partial on a request. So let's try that. So we can add a header, for example. So let's see. We'll do another example here. All right. So that's a simple one. What about def? So request.get, right? So let's wrap the get method in requests, requests lib. Let's try that. Thank you for including your nickname. Hey, yeah, thank you for doing. Hey, Colin, good to see you. Colin, welcome on in. Good to see you. I watched your how to make a randomized password video. That was pretty great. You did good on that. You're watching just a little distracted. Oh, well, careful. Hey, Mohammed called life. Hey, everyone. Moment called life. Hey, how's it going? Moment called life. Good to see you. Welcome on in. What is the same for C++, but C++ just refuses to go away? C++ is sticking around because it's very heavily used in AAA games, in Unreal Engine, right? That's where C++ is used. Mostly AAA games and some other foundational apps and some legacy apps. So C++ and C power a large majority of the internet, right? Whereas Java is mostly application-driven, user applications, maybe a few server applications. C is a foundational language for the internet itself. And we're probably going to see C stick around for a while until there's more replacement of C with Rust. That's what we're going to do. Yep, Rust will take over. Young CR1S, you got it. Rust is going to take over. Apparently there's a cool language I'm looking for. It's called C major. Is that a language? I haven't heard about that one. Are you talking about C sharp versus C major? Are you playing a play on words? Is that what you're doing? It's also used in quants. Yes, exactly. So C is also used for financial money making. We're making all the money. The thing is, C has billions of lines in infrastructure, and it ain't going anywhere for a while. Yep. It is one of the largest, most widely distributed languages for heavily focused. Yeah, we use C heavily for hypervisors and programming at Microsoft. Young CR1S makes a lot of sense. Powerful language, can manipulate what you need to when you need to. GDScript is like Python. Good performance. If actually AAA Studio work on the engine, it would be the same level as Unreal. Are you serious? And one they can rebuild with Zig and Rust. Well, you know what? Some game studios are migrating to Rust. I've seen it. They've used it. I've seen it myself firsthand. My friend works in the gaming industry and heavily uses C++. 808 Mustafa. Yep. It's it. Yeah, exactly. AAA C minus. Yeah. There might be someone out there. Well, it would be like C++ is, right, a superset of C. C would be a subset of C, which would have fewer keywords in it. I'm distracted by package tracking. You should actually sleep, but Matt, all right, well, hey, sleep is good, Laurel. It's good, Laura. You want to make sure that you spend time doing that. It's a part of what, wouldn't it be nice if we didn't have to sleep though? If it was optional or if we never needed to? I kind of would like that better. Java developer, how to become best at it? Well, you just practice all the variety of things and then you build apps and then release them. C equals Mogul Bogle? Well, Mogul Bogle is intentionally not even a subset of C. So you can't even call, Mogul Bogle is its own weird random thing. Check out the carbon. What do you think about it? What about the carbon? What do you mean the carbon? Petition to rename assembly to C Yeah. It is pretty, you're pretty close there. You're pretty close because that is pretty close to what it is. What if an Anaconda language in competition? I think there actually is Anaconda language versus Python. Is there actually a language for this? Let me just find out. Python is a programming language while Anaconda is a distribution of the Python. Okay. So Conda, got it, Conda. Mini Conda for language packages and the runtimes. It's not a separate programming language, but it's not a competition. It is a part of the set. Your brain says less is more. You're right. Less is more. Always use the minimum that you need. The Carbon language. Let's check this out. Carbon programming language. Let's take a look at this. I've not seen this. Experimental programming language developed by Google engineers. Oh, as a potential backward compatible successor to C++. Backward compatible? Really? Wait, why? I mean, just make a whole new language at that point. It's designed to address some of the C's perceived shortcomings and complexities. Oh, focusing on large-scale adoption and migration of existing C++ code bases. All right. Focus on providing modern language to integrate seamlessly with existing C++, similar to TypeScript. Oh, so it's a superset, bidirectional, easier learning curve, modern features, safety, being designed with improved memory safety features, regular bounds checking, null safety mechanisms, and robust concurrency support. So it's basically what they wanted Rust, although Rust is its own programming language. Whoa, just random type about Anaconda's language, bro. We're just checking it out. We're learning new things. We tried it, apparently. Thanks for watching, by the way. Hey, yeah, absolutely. Should I make more videos? Make more videos. Do it. Still experimental. Yeah. And apparently, if it's still experimental, and I remember hearing about this language, then that means they probably abandoned it at this point. Is it still? Roadmap. What? Wait. They're still going. It's still going. Viable product in 2026 at the earliest. I thought they abandoned it. Wait. Is it abandoned? Is Carbon abandoned? Is it abandoned? Well, it's spell abandoned, right? Google knows what's going on. It knows what's going on. Been a while since I've been here. Hey, Domalier, good to see ya. Joined your stream. You stream a lot later here. Yeah. It is. It's late in the night for you guys. Legacy codebase. I thought it was legacy at this point. The program language is not abandoned. It remains highly active and long-term experimental project. We're learning new things. C just binary, right? Just the binary. Instead of 1 + 1. Oh, wait. Oh, I see what you did there. Yeah, I see what you did there. So that is, yep, binary. 1 + 1 = 2. In the binary. Very nice. Torva. Playing with binary there. That's a big amount of binary just to add a really small, tiny number like that. Well, yeah, it's Google. They might have sort of abandoned it. Right? Exactly. They might abandon it. Whoa, just a random type that Anaconda language, bro. I know I did. I didn't know. I thought there might have been one. You never know. You never know. All right, so let's do Savon's idea here real quick. Let's do Savon's idea. So we want to wrap the request lib. So what we do is, hey, header equals, and we will put, let's see, headers equals, we'll say user agent. Let's see here. 1 second. User agent. Changing the music up there for a sec. It was a little distracting. Let's see here. Oh, I want to grab the user agent. Where is it? where is it? All right, so grep-I user, let's see, agent. Let's try agent. That would be in web scrape. All right, let's see, agent. Here we go. Grab that really quick. Okay, you say a user agent. Perfect. Okay. Make it pretty. Looks good. So what we could do is we can say Chrome. Chrome equals partial. And we say requests.get. And then we say headers equals headers. And that should work. And then we just say Chrome, or I guess Chrome fetch. We'll say Chrome get. Chrome fetch, like that. And then we'll put ps www.google.com. So now I look like I'm making a request from Chrome, and we're good to go. All right. Let's see if that works. Okay, so result equals, or I guess we should call it response. It's the I want this copy paste I got. Yep, you got it. Cache tools can use TTL time to live. Yeah, Crow engineer, you know it. That's what we did. We did that earlier. So let's see, where is it? Function tools. So we did that here, which is really neat. It's really, oh wait, so cache tools is different than function tools is what you're describing, and keep cache available for a certain amount of time. So you could put a TTL on it. So it's time to live, which means that you can give it a timeline. So that way you can cache for a certain amount of time, because you know it's going to be refreshed, but you want to cache it for a little while and then clear it, say after 5 minutes. You can pickle or JSON and save cache data. File, load and save cache data from each star Python call. Ooh, you're talking about some performance improvements there. I see. That's very nice. So let's see here. All right, so let's see. So print response.text. Can we do that? Will that work? All right, requests. Did we type that wrong? Oh, I didn't even import it. Import requests. There we go. Try that now. Hey, look at that. All right, check that out. Oh, that's so good right there. Oh, that's great. Okay. So for example, this is Savon's idea. This is TTO cache for 80,000 seconds. That's a lot of seconds. Wait, hold on. That's a lot of seconds. Python, let's say 80,000. 1, 2, 3 divided by 60. That is 1,333 minutes. Divide by 60 will be 22 hours. That's a long cache. That is a very long cache. All right. Let's see what else we got here. What else we got? Okay. I'm going to get going here, Greg. Yeah, that would be fine. Okay, so what else can we do with function tools? I'm actually kind of curious. So we did a wrapper. We did the response wrapper. We made the Chrome fetch like Savon was describing. I think we could do more. Let's see if we could do more. All right, let's go back over to it. Let's see here. You look fake. Hey, how's it going there, Justin? We're real. We're real. We're not fake. We're not fake. We're real. You look fake. Well, you know what, Justin? Say Justin no blares. Is that how we say that? We're real. I mean, as far as I can tell. Aren't we? I'm pretty sure we're real. Bro, according to you, CGPA matter more than skills or not? If you're talking about some sort of credential, skills is way better. Hey, John, thank you for saying skills far more important. What you can achieve and accomplish is way better than having a credential. You can't do anything with a credential. You can't, because you can get a credential and not get the skills. It's very possible. What's the difference between functional and non-functional programming? Well, functional programming is typically involved, it's non-empirical. So you got empirical programming, which is you order like a standard order, and then you've got functional programming where you typically use a lot of functions and then call on. How do you do that? You can define functions dynamically. So dynamic functions is what that is about. So you can build functions. So you can have like a builder factory or a function wrapper that defines a function and returns a different type of function. So if you want to do functional programming, all right, let's do it. Let's do some functional programming since you guys asked for it about. Well, let's do a little bit of functional programming. It used to be my favorite. I used to do functional programming all the time. I was religious about it. It was so fun. I loved functional programming. Your company filtered out based on that? Yeah, your credential. If you're applying, you need to. You know what? I don't know. You want to put your skills on your credentials, your resumes and things. Nice to see someone who's so passionate about something and doing a live stream to do it. Yeah, thank you, John. I love this. This is my favorite stuff. Like most high-paying jobs that I can do are filtered because of low GPA, I guess. Well, don't put your GPA on the resume. No one checks. No one goes to the schools and checks. Functional was a nightmare in JavaScript to me. Let's do some functional in JavaScript then. All right, so we're gonna do something a little different for a second. So we will say we're gonna put a JavaScript file in here and we're gonna run it by functional javascript.js. All right, so you've got function. You name your function. Make a function. Another function, right? And then you got some param. Say a param. I don't know what the param is. And then, wow, we're getting into JavaScript here. I forgot how to do this. I haven't done a little bit of JavaScript for a while. Let's see. I think we can remember. Node. Let me say, what was this called? This was called functional. All right, functional JavaScript. Okay, perfect. All right, we're going to pivot over to JavaScript for a smidgen. Then you can say function, and you define another function in here. Wait, let's see here. Eyes for gaming. Okay, so we say EYES gaming. And then you return EYEs. You could do that. That's something you could do, right? So essentially, there's lexical scoping and closure. So let's say let number of calls equals 0. And so number of calls plus, and then you say return. Actually, what we do is return this. Perfect. 1, 2, 3, 4. Okay. So then what we do is we put, say, trying to think of a good way to, well, here's what we'll do. We'll say console.log make, we'll call this a function. Ease gaming equals, paste. We should make a function which defines this variable, returns this function, and then returns this. So now what we could do is we say eyes gaming return, and then we should be able to run this a whole bunch. And I think it should, if we did it right, it will allow us to have a cached or essentially a scoped variable right here that will increment the number of times that you call the function. So basically you created this sort of like little factory. It's kind of like a really neat way to encapsulate functionality and state all together and then return an inner scope that you can execute and then manipulate variable names and other things inside of this closure, right? Inside the closure. There you go. But you can do functional programming in Python as well, right? Yep, Common, you absolutely can. You can do exactly the same thing. You know what? But Eyes for Gaming was talking about JavaScript. So we switched over to JavaScript for a second. Oh, wait, I meant the .prototype prag. Yeah, don't use prototype. Don't do that. Don't use prototype. That's an internals of the, you don't need to use prototype. Don't do prototype. You can do, all right, array.prototype merge. Yes, okay, so that is one. All right, so Eyes for Gaming. You just listed there one sort of okay use for the prototype. So there's what do you call it? Foundational classes that exist inside JavaScript, right? Like the array. So you get the array. You can say array.prototype. You can say, whatever you want, right? Eyes equals a function that returns, I don't know, like a number, like, or something about, right? Returns this. We can return self, right? So let's just return this. This isn't defined. Wait, shouldn't that work? Wait, that should totally work. Oh, I gotta spell properly. I've got Sam who? It's called meta class. Is it? Oh, meta class. Yeah. Okay. Prototype is from the Netscape days. I remember that. Eyes Gaming. Hey, Kyle. Good to see you. Welcome on in. Is this Sam Altman? Hey, Arrow. Good to see you, Arrow. Report. Ooh, good to see you. Welcome on in. Functional programming has become non-functional syntax for errors. Less than a few. You could do. I used to be in love with functional programming. It would be like my favorite way to do it. That was before ECMAScript 6 came out. The later version of ECMAScript that had native classes. This is the best in JavaScript. This is the best way to sort of define a class, essentially. So, and then you can make instances of it, right? It's an instance of it. So let's see, a equals 1. So then you can say a dot, what do we call it? EYES, and return the self. It returns self, which is a reference to the self class. So you could do that. You could do that. Also, node functional JavaScript. There we go. I don't know if you see what we're doing here, but see how the lexical closure works here? We've got a variable that's defined within the scope of the make another function. And you can then mutate this variable here every time you call the function that we returned. So that is one way to use functional programming. I kind of like it because then you can find other functions, function, other function, right? And you can do stuff here. You can do do things, I don't know, whatever you want. Do other things, right? You can do a lot of stuff. Fun fact, JavaScript classes are just coding for prototypes. Are they really quantified? Really? That is all right. I guess the more we know, at least you don't have to deal with the prototypes directly if you're defining in a way that's syntactically pretty and easy to understand. More functions, right? More functions. Yeah. Actually heard was better than ES modules for browser compatibility. Well, yes. That is ECMAScript. And then ES modules is newer. Does JavaScript have an interface or abstract class? Does it? Does it allow inheritance? Well, technically, yes. You can do that pattern. You can do that pattern. Absolutely. 100% you can do that pattern. And it's called like a this versus that. You have to keep track of it yourself. So when you're referring to this, it refers to this scope right here, right? This scope. However, let self equals this. This right here, this particular pattern allows you to reference the self upper class, right? And so you can say self and then reference the self here if you wanted to. And then you can go a step further and then override methods, do inheritance, call self, whatever other methods that you've got there. So there's patterns that you can use here. What this really mean in JavaScript? What? Let's see. I'm trying to figure out. What do you mean? There is a new way to using hashtag variable names. Is there? I've not been up to speed on that. There's a hashtag, you say? You can do that? Tell me more about that. Tell me more. I'm actually curious about that. TypeScript, ECMAScript, JavaScript abstractions are wild example of how not to design a language. They're basically syntactic sugar. You got it. One instructor dared us to run as many functions in Java as we could and run it successfully. It was a bad idea. What happened? Did you hit like a stack exception? Stack Overflow? What happened? Yeah, private fields are stored now. Yeah, exactly. You figured it out. That's what it is. You got it. By this, I mean the this keyword. Okay, so this is the scope to the current, essentially the current scope, which is the function. So this, so this equals, let me say, this is equal to this, right? So if you wanted to, you could say self dot other, a public function, right? Public function equals, public function equals, we'll just say arrow, we say console.log, it worked, right? You could do that. So this is something you can do. Self is this. So then essentially it allows you to, I think you can, what you can do is say, make another function dot, what do we call it? Public function? Okay, we call it public function. Run it like that. So I'm pretty sure that only works, it'll only work if, right? Because this, that won't work right away. That is, I'm trying to figure out, that might, function, let's see, how do we do this? Return number of calls. I think we need to return the self. We got to return an instance of it. So if we run this, it'll return this. I need to think about that for a second. There's a way, there's a really good pattern. There's a really good pattern that allows you to create public functions and private functions. So I'm trying to figure this out. I'm trying to remember. Instead, I suppose what you could do is say, just return self. So what we do is we say, we'll hide this. We'll hide this real quick. There we go. And then we will make this. And then what we could do is, I think, eyes dot public function. That should return, that should print on the screen it worked. That's what it should do. That should print on the screen it worked. I'm pretty sure. Also what we could do is we could do this. We could say self. And thank you for hearts and reactions, you guys. Good to have you here today. All right. Python is getting tail calling soon. Wait, what is that? So better recursion? Is that what that means? I'm not familiar with that. Tell me more about it. Maybe a singleton of self syntax. Yeah, that's basically what this is. Yeah. So what do we got? We got eyes gaming. We turn this, so we can add this here. Paste be this. Okay. And then make another function. We say self, something like that. If you wanted to, right? So if you wanted to access both, is that gonna work? It worked. See, I told you. So you can make like public functions. You can do other, although of course I'm returning it directly. But you are accessing the core. I don't know. I don't say it's best. Eyes for gaming, yes. Crashes and overflows, but they were not so friendly. Repeating patterns, creative thought, is it? So when you do that many calls on a functions, yeah, there you go. It would cause some issues. Stephen, what functional principles are we showing here? Just closures. So you see how we got a variable name here, and then we can iterate. We can iterate on it. So we can increment basically. Well, oh, I got it. Oh, let's see how to see. Oh, return function self eyes gaming. So what we should do is we should say, I like this one better. Eyes gaming dot public function. That's what we should do. I like that idea better. Let's do that. Let's do eyes gaming. And then what we can do is we return eyes gaming like that. Perfect. This is better. I like this pattern better. That's a lot better. Okay. Get rid of that. It's not, I mean, you could, what we could do is just say self. I mean, we could call, if we wanted to, we call it self, return self. Let's delete that. Self here. We do self. I think that's better. You could do this. Perfect. Okay. Public function, self, and then we just say public function. And now both of these things work. So the public function should work and we should get incrementing at the same time. I'm pretty sure. Let's find out. Let's find out if it works. All right. Well, I'm actually kind of curious to see if you guys have the same thoughts. All right, let's try it. All right. Will this JS crash or work? It'll crash. So I'm going to ask you guys real quick. Let's see. Crash or work? Okay. Let's see. I'm kind of curious if you guys... I'll pull it up on the screen so it's a little bit easier to see here. Basically, it's this right here. Okay. I'm cleaning it up so it's easier to read. Perfect. All right, 15 lines of code. Will it work? Will it crash? I think it'll work. I think it's going to work. Works, maybe. I know, right? It maybe work. Hey, Muskin, how's it going? Good to see you. Welcome on in. Happy Thursday. Happy Thursday, you guys. Good to have you here. If you parse a function as a parameter, do you have to write callable? Parse a function as a parameter. Oh, pass it. No, you do not. Soki, you don't. You can just straight up use it as a variable. JavaScript rarely crashes. Yeah, JavaScript itself rarely crashes, though we could hit like some sort of stack exception or something. I'm just trying to say whether it's going to work or not. Tail call optimization means that when a function calls itself, as the last operation, the interpreter reuses the current stack frame instead of creating a new one. Hey, yeah. Now you don't have massive stack overflows. That's pretty grand. That's grand. Quantified quantum, that's great. Crashes and overflows, but there were not so friendly repeating patterns. Oh, I got you. I read that one already. I got you. It'll crash, bro. Jay, how's it going? Jay, good to see you. Welcome on in. JS notoriously knows for hitting errors and counting to produce unexpected results. It sure does. All right, you guys, we're going to find out. And we've got, let's see. I know we started off with Python function tools, but you know what? Some people were saying, hey, let's see if we can do some JavaScript. All right, we'll do a little bit of JavaScript. This pattern we are using, does it differ from the principles of closure? It is closure, Alberto. You're right. This is essentially, we're using closures here. So we've got a closure here, and then we've got an inner function, and we're returning the inner function, which gives us access to private variables. Like this variable right here is private. It's a private variable. You cannot access it from anywhere. There's no way to access that variable except for calling functions to perform actions on that variable, right? So let's see if it works. A wink, await. Let's do it. Let's find out. All right, you guys, we'll end the poll here. Let's see here. Everything points to JavaScript for some reason. Almost every language. There you guys go. Alberto, thanks. Yeah, you're welcome. All right, let's see if it works, you guys. It worked. You're right. See, I told you. Hey, this is the first time I wrote JavaScript in like a year. Well, I mean, yeah, pretty much. It's like freehand JavaScript. And we even did some functional. Closures there. All right, you guys, those of you answered, it worked. Hey, Laura Maxwell, thank you for the 20. Appreciate it. That's really great. Thank you so much. Good to have you guys here today. Organic artisan JavaScript. Thank you so much. W, exactly, for our listen to you. You got it. All right, so that was some JavaScript. And I'm going to add that to the Git repo. Git add star.js. And be like, git added, git status. And people are like, what are you doing? What are you doing with this JavaScript? Let's see here. What was it? Git commit added JavaScript. We added JavaScript. I don't know why we added JavaScript. You're going to have to figure out why, though. Yep, exactly. JavaScript. You got it. That is a great... I'm so glad you guys are using that. That it was like emoticon or emoji. That's really good. That's a pretty good one. I remember when someone was like, there's no logo for JavaScript. There is no logo for JavaScript. So someone was like, I'm going to make one. And it caught on. And it just became the standard logo for JavaScript. That was like, was it 10 years ago or so? I remember that. I remember when that happened. Crazy. All right, let's go back to functools. Let's wrap up with one more functool thing, and then we'll do the RUX's memes, and then we'll wrap up for the day. Bro, hey, wait, Laura Maxwell, thank you for another 10. Thank you for the thumbs up. Hey, that's great. Thank you so much. You're making me feel great. Appreciate it. That is like my gratitudes to you is what I want to say there. My gratitudes. Thank you. You're getting a major internet issue. Uh-oh. That's a problem. I had that yesterday. Thank you for the party poppers, you guys, in the hearts. Thank you so much. Getting ideas. I can continue stream so you can do memes reactions. I will be on tomorrow. All right. RUX 10,000 sounds good. You got advantage 2 quantified quantum sounds good. Hey, Kumal, or is it Kumal? Hey, good to see you. What's up? Welcome on in. Happy Thursday. We're gonna do one more functools thing. Functions tools. Let's see. We did cache. We did wraps. Let's see what else can we do? Another good functool use. All right. Let's see what else we got. Let's do one more. And then we got to wrap up here. Cached property? Wait, what? That's weird. What about CMP to key? What is that? Useful when you have a legacy comparison function returning and need to use it with a modern Python sorting. What? How does that work? All right. Single dispatch enables function overloading by allowing you to define different versions of functions based on the data type. Oh. Hey, Laura Maxwell, thank you for another 100 joules. Whoa, thank you. High five. That's so great. Yo, you're making my Thursday today. Wow. Appreciate it, Laura Maxwell. Thank you so much. Good to have you here. That's great. Thank you. My gratitudes to you. You're making me feel great today. Function only for caching, is that a real purpose? Yeah, exactly. If you've got some functions that make external API calls and it slows things down, maybe you've got some disk access, you want to throw a cache around it. And you can do cache. You could do that. Okay, so let's see here. Let's do a poll. You're becoming rich, bro. I know. Thank you for Laura Maxwell making me rich today. Thank you. Yeah, it's Kumail. Oh, Kumail. Thank you. Everybody gets it wrong. Kumail. Okay, Kumail. We got you. Kumail. All right. So let's see. Well, which functools last today? All right. So which one's the last? Should we do CMP to key? We'll do CMP to key, or total ordering. I don't know what that is. Or let's see. I think that's it. Is there something else? Cached property. All right. Which one should we do? All right. This will be the last one for the day, and then we will head on to the memes and we'll wrap up. That one was cache tool. All right, got it. 2 libraries for caching. Something different. They're basically the same thing. The cache tool probably give you more options like TTL, time to live, right? Like you were naming earlier. You're awesome. I wish I could do more. Well, thank you so much. It's making me feel good. After like yesterday, we had some internet issues. We had a little bit of internet issues yesterday, and it caused some disruptions. And so I'm so happy that you guys are hanging out with me and doing some Python. This is great. Okay, got it. Yeah, Ice for Gaming. Exactly. All right, so cached property is the one that's currently in the lead. Let's start looking at cached property. Let's learn this. All right, so examples of cached property. We're gonna learn about this one, and we're gonna type it out ourselves onto the terminal window. All right, so we'll call vi cached underscore. Oh wait, nope, we got a new one. We got CMP to key. That one took over. Never mind, we're doing CMP to key instead. All right, vi CMP to key. .py. All right, we're doing that one. That one took over, you guys. CMP to key. Apparently CMP to key. All right, Python, JavaScript, and Rust. Yeah, there you go. Full stack now. You're literally in literal meaning. Those are the languages. If you were to list 3 languages, those are the greatest of all of them. Modern day greatest languages to use. Okay, let's learn about this. All right, let's do this. Let's do CMP to key examples. Let me see here. All right, so let me understand this. Compare items. Okay. CMP to key, sorted. Okay. So this is going to compare items, and it's going to be, okay, A to B. Kind of get it. Let's look at a different one. Numeric. Let's do a numeric sort. This is easier. Come on, you already started cache property. I know. It's the poll took over. It won. Maybe we'll do cache property later. We only have a little bit of time left, so we got to get going. Let's do a numbers. Okay, so let's do numbers. Say numbers equals 7 2 9 4 1 6 2 5, something like that. All right, so we got a bunch of numbers, unsorted numbers. Then we want to define a def sort, so we A comma B, something like that. Okay, and then got it. Okay, right. So you can do this because you need to return a positive number, 0 or negative. Positive number, 0 or negative when you're doing a sort algorithm. So you can directly do A minus B. Return A minus B. So if you do like a positive one, right, that means that the number goes in front. A negative one means it goes behind. 0 means it doesn't change position at all. It doesn't change position at all. All right, so we're going to define our sort function. And what we'll do is, since it's such a tiny little baby function, we'll put it on one line like that. One line, there you go, one line. Okay. And, common. Just to let you know, your video that you did, the short video on generating a random password, you inspired me. You inspired me to do it. Look, right here, check it out. I was like, I wonder if you could write a random password in one line of code. You inspired me to do this, Common. This was you. This was because of you. How's it going there, Anthony? Good to see you. Welcome on in. Welcome on in. Have a great night. Got to run. All right, Laura, thank you so much. A great Python analysis. Thank you. Thank you for the jewels. I appreciate it. Have a great day. You got to dip out. Good luck. I hope you have a carefree. Sounds good. Ice for Gaming. Thank you. So, Common, if you're still here, Python. I wrote this little quick function here. We gotta, hold on a second. Oh, that backslash. Okay, we gotta take out that backslash. Okay. Take out the backslash. C dot. Okay, backslash. Oh, wait, no. What is that? What do we do here? Random. Let's see if that runs that. Oh, wait. Import numpy. NumPy. Spelled properly. Okay. Random. All right, we got to import random. Okay. Let's see here. 10. So 0 to 60. Oh, right. This has to be 70. There we go. You inspired me to do that. So comment yourself. Oh, wait. 60. It's got to be 69. Nice. You inspired me. Comment. I had to cut it because of the short time and limitation. Did you? Well, there you go. You inspired. I wrote it. I was like, I want to try it now. Do all the Python devs love creating unreadable one-liner code? Yeah, I know, right? So here's a random pattern. Then you can say I want 1,000 random characters, or 10,000 random characters, or just like 10. You could do 10, right? So I wanted to try it. That was because of you. I just wanted to share that really quick. Okay, so let's do sorted. Let's see here. Let's see. Sorted. Let's see. Import. From functools. Import C. What is this called? CMP. Let's grab this here at the bottom of the screen. Copy paste that here. Import CMPT. Okay. All right. Sorted. Let's see. Okay. Print. Sorted. Numbers. Keys. So was it CMP? Sort. Did I do it right? Is that it? Did we do it right? I'm wondering. I'm really curious about it. I think we did. I actually think this is pretty great. I'm really excited about this. All right. So it's a quick little 4-liner here. Will it print? This is the last thing we're going to do before we head on to memes, and then we're going to wrap up the stream today. The last thing we do before we wrap up the stream. All right. So did this work? Will this Python code sort the numbers? Yes or no? What do you guys think? Oh, where's my alarm? If you heard it, that was my calendar. We gotta get going here pretty soon. We only got 10 minutes. We got 10 minutes. We gotta get going. So good to have you guys here today. So 100% yes. Yeah, I think so. Check out his YouTube playlist on the Python repo. Yeah. How much time takes to compile a decent Rust project? Let's say Z editor. Well, compile, if it's got a lot of dependencies, it could take several minutes, like 3 to 5 minutes. Exactly, Torah, 20 minutes. Well, in this case, we got just 10 minutes. Just 10 minutes. Let's see here. You did write it in one line? You did, Common? That is awesome. All right. So for functools, CMPT. Did I do it right? I'm gonna cheat really quick. See, CMPT key, numeric comp. Yep, comp. I think I got it right. I think it's right. If it's not, we'll fix it, and then we'll go into memes. I was stuck in debugging because I used, instead of using a loop. That's a really, MD, that's good. I like that. Python, all right, I love that. *5. That is wait, that didn't do anything. What if we do that? You got to put something inside it. Is what you got to do. You got to put something inside of it. That's what it is. You got to put something inside. Because if you do it without anything there, it's empty. It's empty. Check out Discord for the full video link. All right. Sounds good to me. All right, you guys. So we got to wrap up here. So I'm going to say, all right, did it work? All right. Who is right? So CMP. Are we going to get a sorted string or a sorted number list? Are we going to get a sorted number list? No, we didn't. It didn't work. What happened? Sort got unexpected word keys. Oh, is it key? We were off by one letter. There it is. Yep, there it is. One letter. Misspelling. But you know what? We were close enough. Hey, how you doing? We're doing good, Edward. Welcome on in, Eduarda. We are doing very good. Thank you for asking. We're going to wrap up now. We just finished doing some Python function tools. We did some closures in JavaScript. It was unplanned, but you guys asked for it. So I'm like, sure, I'll show you how to do a little bit of JavaScript functional programming. You voted for no. Technically, you were right because it was this key right here. So right here. See that right there? Right there, you guys. Go to beat right here. This. The keys, the S right there. This right here, the S. That's what threw it off. So technically, you were the most right. I'll make a sorting video as well. Come on, you should do it. Make a sorting video too. We have a saying, I diamond. Anthony, I diamond. All right, you guys, we're going to wrap up with memes, and then we got to head out for a meeting. It was so good to have you here today. Memes in the chat. All right. Senior devs. After adding 4 layers of abstraction to avoid simplicity, you guys, you got to stop doing that. You got to stop adding abstractions that are well organized and beautifully architected. You think it's good. You think it's worthwhile. It's not. You got to keep things simple. I'll tell you why. Because we wrote a powerful stack in Golang that was phenomenally abstracted for future integrations, additional functionalities. We added a lot. And it was 40,000 lines of code. It was ridiculous. Oh, technical debt. You got it. Over engineering. It got it. And we rewrote it in 3,000 lines. The same thing. And it was so simple, just as flexible, and actually, in fact, a little bit more. 30,000 down to 3. That's a 10x change. It was so good. It was so much better. You got to stop abstractions, you guys. Double production, right? Samsung, Hynix, SanDisk are planning to double NAND memory. All right, production, right? No, not production. They're gonna do prices, right? Doubling the prices, not production. When hardware manufacturers announce they're doubling NAND memory, you gotta know. I work with models. Others, me. Yep, exactly. You guys, we work with a machine learning models, right? The weights and biases, the parameters. We do the parameters. In full self-attention, right? That correlation coefficient, you build it into the matrix. You build it in, and you call it self-attention. And now, all of a sudden, it's a whole new thing. It's large language models. And the ability to write, generative AI. You just add in the correlation coefficient directly into the model. Who cares about feature development anymore? Just correlate the coefficients. Docker. Edit. Eating RAM? Telling lies? Yes, Papa. No, Papa. No, Papa. Open your mouth. I don't get it, but it's funny. I like it. I don't get it. I don't get it, but I like it. L-pole? What do you mean L-pole? I don't know what that means. Microsoft is the best? Yes. Can floating point numbers be irrational? They sure can, yes. Floating point numbers can indeed be irrational. That's because irrational numbers cannot be expressed as a ratio of two integers. Non-representing, non-terminating decimal expansions. Yep, exactly. So they're essentially unlimited. They never resolve. They continue to divide forever. Windows, can I install this 25-year-old software? Sure, no problem installing now. Linux, can I install this 25-year-old program? It's already installed. Hey, Monkey D. Luffy, welcome on in. Good to see you. Happy Thursday. We're wrapping up with some memes. We were headed out to a meeting. Really glad to see you guys here today. I had a lot of fun. Just made my first pull request to main. The main branch. Oh, straight to the main branch. Oh, wait a second. I recognize that. That happened to us too. 30,000 lines minus 3,000 lines. That is ridiculous. Yeah, exactly. You don't want to do that. This is a mistake right here. Don't do that right there. Don't do that. Cat block activated. My new ad blocker is working. Thank you, kitty cat. Blocking the ads. Also on a really old CRT in Windows XP. Windows XP, I don't know if you guys know about that. You all probably don't. It's probably... I will show you a second application not responding. Task manager. Yeah, we're coming. I'm coming for you. You know what happens if you're misbehaving? Dang, that's so many changes. Will definitely cause problems. You think? Just a few. Senior devs after adding 4 late. Oh, we're done. We did it, you guys. All right. So thank you so much for hanging out with me today. I had a lot of fun. We'll be back tomorrow with some more Python probably. I still very much really want to start working on Neva's. I've got Neva's repo open here, and we will go through PyTorch. We'll start with some PyTorch. I want to get more into the PyTorch matrix manipulation functions because I want to maintain an unbroken graph. It's been a pleasure, Torva. Thank you. We're heading on out, you guys. Enjoyed your time. It was great to spend time with you guys today. Had a lot of fun. Lots of conversations. We did JavaScript today. Yay. And we also did, yep, exactly, PyTorch. So we'll be doing PyTorch tomorrow. What can we read in preparation to the PyTorch stream? I will post it in the share link here. This is what we're going to do tomorrow. So this is what we'll do tomorrow. I'll put it in the link share. This is Neva's. Tomorrow we will do Neva's PyTorch matrix manipulation functions for an unbroken graph. Party poppers, you guys. Thank you so much for the party poppers. Party popper. Peace. That's the plan for tomorrow. Monkey D. Luffy, bye. Thank you, Common, for seeing. See you, Savon. Thank you, Torva. Bye, guys. Have a great day. We'll see you guys tomorrow. See you, eyes. See you, Fireless, in a few. Bye, everybody. See you tomorrow.